Now that you have a little bit of background on what causes seasons and hopefully at least a decent understanding of it, we're going to look at it in some more detail. So to start out, let's first review that the Earth has an elliptical orbit, and that means that it is an oval orbit. And we know that because of Kepler's first law. And that's why that's not bolded, so you don't need to write it down. So the orbit is an oval, and here is the sun. Now, there are times where the Earth is closer to the sun than others within its orbit. So when the Earth is over here, it's furthest from the sun, and you would think because it's far away from the sun it would be colder, but that is incorrect. The Earth is furthest from the sun in July. Okay, the Earth is furthest from the sun in July. The Earth is over here and closest to the sun in January. And I always like to bring this up because there are a lot of students who will think that seasons are caused by the Earth's distance from the sun. It is not caused by the Earth's distance from the sun. Not at all. It is caused by the tilt of the Earth, which you saw in your lab. And I just want you to be sure you really take this in. We are closest to the sun in January when it's coldest. And we are furthest from the sun in July when it's the warmest. So that alone should show to you and kind of prove to you that distance from the sun does not matter, okay? Distance from the sun does not matter. And I'm saying that again and again because it is so important to make sure you remember that. Typically, they do put that as an answer choice on test. And I know I like to put that as an answer choice on test because it's a common misconception and we want to make sure that you are not falling for that misconception. The seasons on Earth are not caused by the distance from the sun, not caused by the distance. It is caused by the tilt. If you ever give me anything other than the tilt of the Earth as your answer for seasons, then I just may cry, okay? It is not caused by the distance because we are coldest when we are closest and we are warmest when we are furthest from the sun. So hopefully that is now ingrained in your heads. You do not need to write down you do not need to remember. If you've already written it down, it's fine. But you do not need to remember the names of when the Earth is closest or furthest from the sun. The point of this is just to make sure that you at least know the month we are closest and the month we are furthest to kind of help get rid of that misconception. Okay, so let's move right along. Okay, so what causes seasons? We already know this from the lab that you did, and I already said it on the previous slide. But the seasons are caused by the Earth's tilt. By the Earth's tilt. So the Earth is tilted about 23.5 degrees. Now, when we talk about the Earth being tilted, I do have a globe on my filing cabinet you can always look at. But if this is the Earth's axis does not go straight up and down. It's tilted at an angle, 23.5 degrees. That is the same angle that you set your Earth to in the virtual lab. And that's when you started to notice the differences between the indirect and the direct light. You started to notice the daylight changing, and then you also started to notice the temperature differences. That was because you had tilted the Earth. Remember, when the Earth was straight up and down, the entire orbit around the sun, it never changed temperatures. The direct and indirect sunlight never changed. And so that's why we know the tilt is what's causing those changes. So when the northern hemisphere, whichever one, is tilted towards the sun, that's when we have our warmer seasons. So for now, we're just going to pay attention to summer. But summer and spring, we are tilted towards the sun. And then like fall and winter, we are tilted away from the sun. So warm seasons, we're tilted towards it. And cooler seasons, we are tilted away from it. Now over here, you can kind of see that you have the Earth and it's showing you the way that it's tilted. So the north, in this case, down at the bottom, the northern hemisphere is tilted away from the sun, which is why it's winter. And up here at the top, the northern hemisphere is tilted towards the sun, and that's why it's summer. Now, if you're not seeing that the Earth is tilted towards or away from the sun in these diagrams, don't worry too much. I'm going to show you this a couple more times, and hopefully it will help you understand it then. So, moving along. Okay, here's a picture of the Earth. You have the sunlight rays being shown on one side. We could always give that a nice yellow color. And so over here is our sun. Yay for the sun. Okay, and then looking at our Earth. I want you to think in your head. Don't say it out loud, but think in your head which hemisphere is tilted towards the sun. Just think about it. If you are thinking that the southern hemisphere is tilted towards the sun, then you are correct. Okay? If you are having trouble visualizing that, then one thing that can help you is if this was actually on paper, or if you had this diagram closest to you, you could put your finger on the northern side of the axis by the North Pole and by the South Pole. And when you did that, you could see which finger, or in this case, which line is closest to the sun rays. And in this case, the bottom one is. So the bottom one is tilted towards the sun, while the northern hemisphere is tilted away from the sun. So if the southern hemisphere is tilted towards the sun, that means that the season is summer. And because the northern hemisphere is tilted away from the sun, the season is winter. Now, we already know, and you've probably have known this for a long time, but the two hemispheres always have opposite seasons. Whatever season it is in the north, it means it's going to be the opposite season in the south. And if you are looking at seasons caused by the tilt, then that should make perfect sense. If you hold your pencil up and you're holding it from the middle and you tilt your eraser towards, towards the board, towards the notes, then that means that the lead part of your pencil has to be tilted away. And vice versa. If you tilt the lead part of your pencil towards the board, then the eraser part of your pencil has to be tilted away. There is no way to have both ends of your pencil tilted in the same direction unless the pencil was a rubber pencil and could curve. Well, the Earth is not rubber and it doesn't curve, and that's why we always have opposite seasons in our two hemispheres. So let me go ahead and clear the screen and we will move right along. Okay, here is another picture of the Earth. Some of you may have noticed that this is pretty much the same picture I just showed you, except it's not just black and white. And I want you to think to yourself, what season is it? Let me pick a color. What season is it right, let's say, right here, where the big red dot is. Think to yourself, don't say it out loud, but what season is the big red dot? Okay, if you were thinking that the big red dot is in winter, that is correct. Now, if you didn't know or you got that wrong, let me show you why. So the equator is right here. So we're looking at which way the two hemispheres are tilted. Well, the northern hemisphere is tilted away from the sun. And if it's tilted away from the sun, that means that it's going to be winter. Well, a lot of students will get this mixed up because I drew the dot on the side closest to the sun. Well, all that means is that it's daytime in the winter. In the winter, we have day and night, just like any other time. Remember, day and night is caused by rotation. So that one dot is going to spin away from the sun in a few hours, and it's going to be nighttime. Just like over here is going to spin towards the sun pretty soon, and it's going to be daytime. Whenever you are labeling seasons, you look at the entire hemisphere. You do not look at the side of the Earth. You look at the hemisphere. Anything in this bottom hemisphere is going to be summer. Anywhere we put it, anywhere on this northern hemisphere is going to be winter. The side of the Earth, left or right, doesn't matter anything except day and night. That is not what causes seasons, okay? The tilt is. So if it's in the entire hemisphere, it's the same season. So make sure that you do remember that and keep that straight. In just a second, we're going to pause the video again, and I want you to look at this diagram, and I want you to label the seasons in the northern and southern hemisphere. I want you to do it kind of by yourself in your head, and then talk with your neighbor If you are not understanding how to tell if the northern or southern hemisphere is tilted towards or away from the sun, that is something that some students really struggle visualizing at first. Tell one of your partners now, because I guarantee there's somebody at your table or there's somebody in the room who understands how to do this. So make sure you are asking them. Tell them if you are confused or lost to make sure that they can help you. So we'll pause the video. I want you to have a moment to check for understanding within the group and within the class, and then we will give out the answer to this. So go ahead and pause the video. Okay, hopefully if you didn't understand this, hopefully one of your peers is able to help you. If not, please email me. Ask some other friends who understand this topic, but make sure that you do get help. This is an extremely important thing for you to know how to do. And the part we're about to do, if you can't label summer and winter right now, you're not going to be able to do this next part. So it is extremely important that you understand this. The northern hemisphere in this case is summer, because the northern hemisphere is tilted towards the sun, and the southern hemisphere is winter because it's tilted away from the sun. So again, if you are having trouble telling if it's tilted towards or away, then you can put one finger on the North Pole and one finger on the South Pole. And whichever finger is more towards the sun, in this case it's right over here, that's more towards the sun. This one's more away from the sun. So because this is more towards the sun, this is going to be your summer, and this is winter because it is tilted away, or it's further not towards the sun. I don't know how else you'd say it. So there's your answers for that. Please make sure you understand this. Let me know, let a friend know, but let somebody know if you are still lost. Okay. So moving along. Why does this tilt matter? Well, it's summer. Summer is warmer than winter because the sun rays hit the earth at a more direct angle. In the lab, this is something that you had to pay attention to the entire time. You had to look and see when the temperatures were warmer, what was going on with the angle of sunlight. Every time the temperature was warmer, that was when you had the more direct sunlight. And remember, we said direct was when it was more of a straight line, and your indirect is more when the line was at an angle. So summer has direct light, winter has indirect light. Or you can just think warm temperatures have direct light and cold temperatures have indirect light. That is a very important thing to remember. So I would put a big star next to it. Warm temperatures equal direct light. Cold temperatures equal indirect light. Therefore, summer and spring are going to have more direct light. Summer, the most direct light. Winter and fall have indirect light. Winter being the most indirect of all of them. So let's keep on going. Hopefully you have that written down. Okay. The number of daylight hours is greater for the hemisphere tilted towards the sun. You already know this because we have the longest days in the summer. And when you're tilted towards the sun, that's when you're in summer. So days are longer in the summer, days are shorter in the winter. And that all has to do with whenever the hemisphere is tilted towards the sun, as it's rotating, it's just facing the sun for a few hours longer than the side of the earth that is tilted away from the sun. It goes out of the sunlight and into the shadow a few hours earlier, which is why the nights are shorter in winter and the days are longer in the summer. So I'm going to move on because even if you're not done copying that, you should already know that because it's happened every single year for us, and you can continue to write that down. Okay. Actually, let's see. I may show you a video. Okay, here's the video that I wanted to show you. This is the Earth, obviously, and here's the U.S. They are going to tilt the Earth to 23.5 degrees, just like the Earth normally is, and just show you a normal rotation of the Earth. So there's the little night bubble at an angle, and so as you can see, the Earth is rotating, and the whole country of the U.S., it goes into day and it goes into night. Now, they're flipping it. They're showing you the view from the poles. So this is where Santa Claus is, okay? So this is the exact same thing. They're just showing you a different angle. Instead of you looking at the U.S., you're looking straight down on the Earth from the North Pole. And watch what happens as the Earth rotates. Does the North Pole, or does this area right here, ever go into daylight? No, it's nighttime. You saw this in your lab when you did the most extreme angles. So just to keep this plain, it's going to stay consistently night. We call this endless nights or perpetual nights. If you've ever seen the movie The Proposal, there are times where, or there's this one time where they're going to bed and they're in Alaska and they have to close these really thick, heavy blinds to close out the sunlight because even though it's 10 o'clock at night, it's still bright as day. That's because when it comes to the poles, they're at such an extreme angle that in the winter, they will have months of no daylight and all nighttime. And in the summer, the poles will experience months of all daylight and no nighttime. When it goes into spring and fall, it's kind of will go like dusk and so on. But they'll have extremely long days and like 2 hours a night, or extremely long nights and like 2 hours a day. So again, you can watch this at that extreme angle. Well, this is going to show you the daytime. So they're going to do the same thing, and you can watch right here the most whatever part of Antarctica, the nighttime bubble never ever hits it. So that means it's in summer, and they have the perpetual day. So same thing for the South Pole. It's perpetual day here, so months of daylight until the Earth orbits away and the hemisphere is more tilted towards the sun. Okay, so that was my little video to help you visualize that. Now we need to look at how you would label all 4 seasons. We know how to label, hopefully, summer or winter when you're just looking at the Earth and the sun. But now we're going to get into fall and spring. And this is very, very simple. If you can label summer and winter, you can label the rest of the seasons. So here you have a diagram. And as I'm explaining this, yes, you will need to draw it. Now, we already know there is only one Earth in orbit. So the fact that it has 4 pictures here is just showing you 4 different locations the Earth could be. Okay, so let's look at location 1, right? Or let's look at location B, I guess you'll say. Whenever you are labeling the 4 seasons, this is important, so make sure you're paying attention. Whenever you label the 4 seasons, you always start by looking at the left and right. You ignore the top and bottom. You always start by only looking at the left and right. So I'm only going to look at location B, and I'm only going to look at location D. For now, I am completely ignoring A and C. If you start off by trying to label A and C, that will mess you up and you'll probably get it wrong. So ignore A and C, only look at B and D. Okay, so let's look at B first. Which hemisphere, and I want you to again think this in your head, do not say it out loud. For location B, as in boy, which hemisphere is tilted towards the sun? Okay, the northern hemisphere is tilted towards the sun. If the northern hemisphere is tilted towards the sun, we know that means it is summer. If it's summer in the northern hemisphere, what season is it in the southern hemisphere? Winter. Okay, so it's summer in the northern hemisphere, winter in the southern hemisphere. Now let's look at location D. Which hemisphere is tilted towards the sun? Well, over here, towards the sun is going to be the southern hemisphere. So that means the southern hemisphere is summer, and the northern hemisphere is winter because it's tilted away from the sun. So as long as you can label summer and winter, then you're good. Now all we have to do is fill in the order of the seasons. And so if you notice, this diagram has arrows showing you the direction that the Earth is orbiting. Now these arrows are important because it tells you the order of the seasons, which way it's going in. So let's only look at the northern hemisphere first. So after summer, starting at B in the northern hemisphere, after summer, what's the next season? Well, after you have summer break, you start school in the fall. So the northern hemisphere is fall. And after fall break, you have winter break. And after winter break, we go into summer break. So location A, the northern hemisphere is summer. And location C, the northern hemisphere is, not summer, I meant to say spring. And location C, the northern hemisphere is fall. So up here is spring. Sorry, that's so messy. And this is fall. So then the southern hemisphere is just whatever's opposite. So if it's spring in the northern hemisphere, it's fall in the southern. And if it's fall in the northern, that means it is spring in the southern. Okay, so again, all I did was I started looking at the sides, location B and D, and I labeled them if it was summer or winter. Okay, so summer or winter. And then I looked at the direction that the Earth was orbiting, and I knew that because of the arrows that my diagram drew for me. And based on that, all I did was fill in the blanks with spring and fall. And I know for a lot of people, they actually struggle telling the order of the seasons, but I found if you can think about it in terms of breaks, summer break to fall semester, to winter break to spring break, and then back to summer break, that students have a better time remembering that. Okay. The other important thing for me to tell you about this diagram is do not memorize it. Okay? Do not memorize this diagram. You need to know this diagram. You need to understand this diagram. If you just memorize this diagram and you think you're good to go, then you're probably going to get quite a few questions wrong on my test as well as the NCFE. And I will show you why. So I'm going to go ahead and clear the screen. So hopefully you're done copying this down. So I'm going to clear the screen and I'm going to rewrite something. Okay. If I'm giving you multiple versions of a test, which I always do, then an easy way for me to switch up version A from version B is instead of having the Earth orbiting in this direction, I change the arrow. And all of a sudden, I have the Earth orbiting in a different direction. And that is going to cause your spring and fall seasons to get flip-flopped. The other thing I can do to change it up is instead of having the Earth tilted in this direction, I can change it and draw my axis this way. Now, all of my seasons are completely opposite of what they were to begin with. So if you remember this diagram simply to memorize it, then you're probably going to get wrong, because when I'm giving a test or when North Carolina is giving you your state test, we're going to change it up depending on what version you have. And so you can't just memorize it and write down your answers. You need to be able to actually think through the diagram and to fill it out. And so again, as long as you can tell what is summer and what is winter, you should be able to do that no problem. Okay. And if you don't know how to do that, email me or ask a friend. Moving right along. So here's a beautiful picture. This is Central Park in New York. Go ahead and raise your hand if you've ever been in New York or Central Park. I know I can't see you, but I've been there once. This is a picture of Central Park in all 4 seasons, and you can tell that they're all very different. The green one is summer, the one with flowers, spring, yellow one, fall, snow, winter, obviously. Here is a picture of Florida, Miami, Florida, okay? The only season you can tell here is spring break, and that's because it's the one that has a ton of people in it. But as far as fall, winter, and summer goes, you really can't tell the difference. When Doug and I got married, we went to the Bahamas on a cruise for our honeymoon. And we got married in November. And so when we got on that cruise ship to go off to the Bahamas, it was very, very cold. By the time we got to the Bahamas, it was in the 80s the entire time. And it was still November. So seasons are going to vary everywhere you go. North Carolina winters are very different than Michigan winters, and Michigan winters are extremely different than Miami, Florida winters. So now we're going to look at why it is that seasons vary so much based on location. And this is somewhere in the north I don't know what kind of animal that is, but that one of the animal that is the summer picture, but in the background you can still see it's snow, and that really the animal is super, super fuzzy because it's still super, super cold even in the winter. I think that's, I don't know, somewhere in the U.S., maybe Alaska. Okay, so seasons differ based on latitude. I know this isn't bold, but you need to write down everything, okay? It's not bolded, but you need to write down everything. We know the cause of seasons is going to be the tilt of the Earth's axis, but these seasons will change or differ based some on your latitude. That you should understand that some, or realize that happens because we know that North Carolina is going to be very different than Florida, and Florida is very different than Michigan, just like I said earlier. The closer to the equator, the warmer you are. That's why in November we could go to the Bahamas and it's still 80 degrees, okay? It's going to feel like summer the entire time near the equator. The further from the equator you are, the colder it gets. So the further from the equator you go, the closer to the North and South Pole you are. And that's when it gets colder. And why is this happening? It's because of direct and indirect light. We keep coming back to that. So we know in the winter, the entire northern hemisphere is going to have indirect light because it's tilted away from the sun. But even while it's tilted away from the sun, the poles get the most indirect light of them all. And so think about it. The earth is what shape? It's a sphere, okay? It's a circle. So if you look at this diagram, the sunlight is hitting the equator straight on. Remember, the straight on arrows were your direct light. That's 90 degrees. That means it's very direct. It's hitting the poles at an angle. That's indirect light. And why is it hitting it at an angle? Because the earth is curving away from it. So the poles are always getting indirect light, which is why the poles are cold even in the summer. And the equator is always getting direct light. Because the equator is in the middle of the earth, no matter if the earth is tilted towards or away from the sun, it's always getting a zone of direct light, which is why it stays warm for so long. Okay? So seasons are caused by the tilt of the Earth's axis. Seasons vary with latitude, and why they vary with latitude is because of the amount of direct and indirect light they get. The more direct, the warmer it is. The more indirect, the colder it is. Okay, that's just a little summary. So I'm going to move on to the next slide. Actually, I'm not going to move on to the next slide. I have one last little video clip to show you about why it is direct light is warmer than indirect light. And these videos are all linked within the notes, so please go back and play them because they're all on Canvas. So what they're going to do is they're showing you a flashlight. So they're holding the flashlight straight up and down. Because it's straight up and down at a 90-degree angle, that means that it's direct. So all of the light, all of the energy is focused in one area. And this guy is tracing that area. Now what they're going to do is tilt the flashlight. The flashlight is at an angle. This is considered indirect. That same amount of light, the same amount of energy that's in the flashlight is now spread out over a larger area. Okay? So when it was shining straight up and down directly, all the energy was in one spot. It was focused in one spot, and that's what makes it warmer. When the flashlight was tilted at an angle, it was indirect, and that same amount of energy was spread out over a bigger area. Now imagine if you have a space heater. If you have a space heater in this classroom and the door is shut, it was in one area, all the energy is focused in that one spot, it could get pretty warm pretty quickly. But imagine if that one little space heater was what was supposed to heat this entire building. The same amount of heat would have to cover a larger area. Well, if that happens, y'all are all going to be cold, and you'd all have to bring a blanket or a jacket because it would be freezing. It wouldn't be able to do that. So the space heater in the one small area with the door shut would be equivalent to the equator, while the space heater just in one area but having to cover the whole building, a larger area, that is more equivalent to the poles, which is why the poles are always cold. So What we're going to do now is you're going to pause the video, and I've got some check for understanding questions that's going to be on the screen, and you can just pause it while the questions are up on the screen. And I want you to talk about these questions, these answers within your group, and then we'll go over them because I want to make sure that you do have a good grasp of this before you take your test. So before I go to the next slide to show you the questions, what you're going to do is talk within your groups about the answers to these questions, and then we will check your answers to see how well you did. So here are the questions, and you can just pause the video with these showing on the screen and discuss them.